This is an alien spacecraft. It crashed in Roswell, New Mexico in 1951. We recovered it and are secretly keeping it hidden in a location in Edina. Now, Junior Genius's goal is to figure out how it works. We've been studying it for some time now and believe it's powered by antimatter. Now, we will go inside on a remote tour with Professor Thomas to see the amount of antimatter and calculate how many gigawatts it will take to start up the engine and fly back to Mars. We will monitor Professor Thomas with thermodynamic heat sensors while he explores the engine room. Meanwhile, outside, Sandra will answer text messages from the parents of Junior Genius. Will, our technician, will disengage the Giggle Flexor to allow the entrance into the ship. Here we go. This is the main galley, and here is the entrance to the engine room. Kids, it's awful dark in here. Let me see if I can feel around for a light switch. Oh, here's something. Wow, cool. Kids, I wish you were here. I may need some help. Uh-oh. Let's see. The professor will need to do some old school math. Pre Algebra. Let's use some stoichiometry in order to calculate the number of moles of plutonium isotope 53 and how many it will take in order to produce enough engine power to travel each way 34.8 million miles back and forth to Mars. Sure wish I had my TI-84. So let's go ahead and try and figure out a calculation here. Wait, what's this crazy machine over here? Flux capacitor? I'm not really sure how to use that. Okay, well, let's go ahead and use some old school. Plutonium isotope 53 is roughly 28.73% parts per million of antimatter. And so it roughly takes 2,754 atomic mass units to travel each way to Mars. We'll multiply that by 2. Then let's go ahead and divide that by 3. Wait. Or do I multiply that by 3? Kids! Oh! I forgot all this stuff. Pre-algebra. Oh, yo, 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 yo! I learned all this crazy stuff in 6th grade. It's been ages. I'm in calculus right now. Looks like we're going to have to do some serious review, kids. Let's go ahead and get started with a review of our pre-algebra. Here we are with the review, kids. Pre-algebra. Let's go ahead and take a quick look at some of these problems here. Number one, first thing we're going to do is we're going to deal with operations of integers, fractions, and decimals. Then what we'll take a look at is positive integers, exponents, square root, and scientific notation. We'll definitely need that when we're going to Mars. Scientific units, 10 to the 9th times 54,000. And we're going to take a look at percentages and then averages. Remember, averages include mean, median, and mode. It's important to understand those particular definitions. We are going to do a quick overview of what you're going to see here, and then we'll take a look at the problem. So we have a total of 8 pages, and then the back page is going to be the answers. Here are some practice problems illustrating the concepts that we saw up here: average, mean, median, mode, basic operations with decimals, money problems. Take a look at the next page. We have adding, dividing, order of operation using Pemdas. We have degrees problems here. We have all this crazy stuff, adding, dividing, subtractions, fractions, and so forth. Over here, scientific notation, square roots, some stuff here. We keep going through here. And finally, we get to the back page where the answers are. What I would like you to do is take a look at page number 1 and work your way through all the way to the back, and then go ahead and turn the video on, and I'll give you a quick, very fast explanation of kind of what we need to know, And you can correct your answers from this sheet on the back here. And if you get any of these problems wrong, and if you have questions about how to answer those questions correctly, that is a great opportunity for you at the Genius Combine to speak with Professor Maracek or one of the assistants. We have everything on video as well. So what I'd like you to do right now is go ahead, pause the video, and we will come on back with a quick explanation to each particular problem. Let's take a look at practice problem number one. Practice problem number one, we are going to basically take all these numbers, add them up, and then divide by the total. So when you add this up, you're going to get 34. Once you get 34, there are 7 numbers. 34 divided by 7 gives you roughly, on the calculator, 4.85. And 4.85, when you look at your answer choices, we can cross out anything that's not 4. We cross those out. And then basically what you want to do here is, on your calculator, 5 divided by 6 or 6 divided by 7. When you do that, 6 divided by 7 is going to give you 0.85. The correct answer, therefore, is going to be answer choice C. Problem number 2, the way we're going to go ahead and answer problem number 2 is this. It looks like we are going to sell the toys for $3. It costs $1.80 to make them. $3 minus $1.80 gives you $1.20 profit. And what you want to do here is $36 divided by 120, and that is going to give you the correct answer, C, which is 30. Problem 3 is a pre-algebra word problem dealing with length in yards. First things first, it looks like we are starting off with a piece of material that is 24 yards in length. We're going to remove some pieces, so let's start with that. It looks like we have 3 pieces that are 3.5 yards long, so 3 times 3.5, and remember, fractions, get them out of there, and we're going to convert those into decimals right away. So 3 times 3.5, that is going to give us 10.5. And then when we move over to the next one here, it says we have 5 pieces that are 2.25 yards long. So it is going to be 2 times 2.25, which is 2.25. Always convert fractions into decimals. When we do that, that will give us 11.25. Then we're going to go ahead and add those together. That is going to give us 21.75. Now, here's the tricky part. It's a multi-step problem, so make sure that you read the problem correctly. It says how much cloth remains. So we start with 24. So 24 minus that is going to give us answer choice A, because 24 minus 21.75 gives us 2.25. Correct answer for 3 is A. Problem number 4, very common. It's a money problem. So let's go ahead and get started. It looks like Philip charged $400 worth of goods on his credit card, and there was no interest charged that month. He made a payment of $20. So let's get started. $400 is what he had on his credit card. He paid $20 off. 400 minus 20 gives us $380. Then we move on to the next month. The next month, he charged $18 worth of goods. So let's add that. 380 plus 18 gives us $398. That is his bill. Philip was charged 2%, so $398. And here's the tricky part. Make sure that when you type this in your calculator, it's 0.02, and you're going to multiply it. If you put 0.2 in there, that's 20%. 398 times 0.02 is going to give you 7.96. Answer choice B for problem 4. Problem number 1, kids, it's the order of operations, PEMDAS. Let's go ahead and spell it out. P-E-M-D-A-S. PEMDAS, what does that mean? It means parentheses, exponents, multiplication, division, addition, and subtraction. If you went straight in order from left to right in this particular problem, you will get answer choice D, which is 30. That is incorrect. Why? Because here, according to Pemdas, we are not going to subtract until the very end. We have to go over here. Before we subtract, we have to come over here and divide. So 6 divided by 2 is 3. 54 minus 3 is 51. 51 plus 6 is 57, and that will give us the correct answer for problem number 1, E, PEMDAS, kids. Problem number 2, it's a temperature problem. Kids, remember, think of a number line. So here we have 0 on our number line or our thermometer, and on the left it looks like we have -8, and on the right we have 24. So how many spaces are in between them? 8 and 24 gives you 32. The correct answer, E for 2. Problem number 3, we are looking for the denominator, the lowest common denominator. So if you look over here, we have 4 and 3. 4 times 3 is 12, and we have 2 and 6. 2 times 3 is 6. The lowest common denominator over here is 6, but the lowest common denominator over here is 12. Well, 6 goes into 12, and you can't reduce this anymore, so the lowest common denominator, therefore, is going to be answer choice B, which is 12. Kids, if they ask you a different question, and they're giving you some monkey business like this, what you can do is you can go ahead and simply calculate this out by dividing. Get rid of fractions and convert them to decimals. If they asked you, instead of what the fraction is, calculate this problem, and you forgot how to do all that, and you didn't want to go through the find the lowest common denominator, what I would do is I would go over here and I'd say 3 divided by 4 is 0.75, and then 2 divided by 3, and then what you do is you get decimals, and then this decimal subtracted from that decimal will give you another decimal. Do it over here for the same thing, and then you add the decimals together to get the answer. Remember, fractions can be a pain in the rear end, so what do? Get rid of them by simply dividing them out and make them into decimals. Problem 4 is a problem I mentioned earlier, converting fractions into decimals. Over here, we go ahead and take our fractions and put them into decimals. 1 divided by 2, or 1/2, equals 0.5. We simply rewrite the problem, add in the addition symbol here, and then put our brackets in here to stay organized. 2 divided by 3 is going to give us 0.666. Repeating. And over here, there's a division sign. And we have 3 divided by 4 is 0.75. Throw in the end bracket. Stay organized. Over here, there is a negative sign here. And then 4 divided by 5, we'll go ahead and throw the brackets on here as well. 4 divided by 5 is 0.8. And we are going to multiply 0.8 from here by 5 divided by 6. 5 divided by 6 is 0.833. Throw our bracket on there as well. And now PEMDAS, P-E-M-D-A-S. The order of operations, it's important for us to follow the order of operations as we saw earlier. We see that we have division, and that's the first thing that we're going to do. We're going to divide out before we add or subtract in here. So 0.666 divided by 0.75 gives us 0.88. And we just basically see how I stay organized. And then let's carry everything down here. And you can see we throw everything nice and organized here. And then we have a negative sign here, subtraction. And now let's go ahead and do multiplication. Both of these, we're going to do division and multiplication before we add and subtract. So 0.8 times 833 gives us 0.666. We put that in brackets. We're going to subtract that. Now, we're going to punch this on our calculator. 0.5 plus 0.88 minus 0.6 is going to give us 0.716. Once we do that, we simply go over to your answer choice and convert them. You see that when we do that, the correct answer here is going to be C, and answer choice C is 0.72. And if you calculate your answer choices, you see that this 1/6 is going to convert to 7.2 because this will convert up. C is the correct answer for problem number 4. Remember, fractions, get them out of there, use decimals. Problem number 5 is a money problem. Remember, we want to get rid of fractions and put them into decimals. Mr. Brown went shopping for his annual office picnic. Let's go ahead and write this down. 7.34, 7 3/4 pounds of burger translates to 7.75. And then we go over here. We take a look at chicken. They've already done that for us. 17.85. And over here, 6.5. And then we just basically add them up. That's 32.1, which gives us answer choice A. Remember, get rid of the fractions, put them into decimals. Much easier. Problem 6, it's a money problem. Let's go ahead and get started. Make sure that you read carefully. You're translating language, English language, into mathematical formulas. So we have 4 students, and 4 students are going to purchase concert tickets at $18.50. So start writing some stuff down. $18.50 times 4. That is going to give us $74. And we continue reading. It says 5 people can get tickets for $80. So if we write 80 and we divide 80 by 5, you see that that comes out to $16. So the question is asking us, how much would each save if they bought 5, they got another person, and they bought the group of 5? Well, if 4 went, they're paying $18.50. If a group of 5 goes, it's 16. So $18.50 minus 16 gives us $2.50, and that will equal answer choice B for 6. Problem 7 is dealing with scientific notation. We are going to add 2 large numbers together. So here's what I did. I went ahead and took 20,000 and I just simply wrote it underneath, and I lined up where the zeros would go. So here's our 20,000, and then I'm just going to draw that a representation of the 3 zeros. Then what we do is we simply just bring 0, 0, 0 down, and then you see we have one more 0 there, and then we have 3, 4, and 2. So I went ahead and wrote that in. 3, 4, 2. All right. The thing to keep in mind with scientific notation is you have to always be aware of where the decimal place would be. In this particular number, since it's a whole number, the decimal place would be here. Now, in scientific notation, all you have to do, don't think of the zeros, count where the decimal place would be, and then go to the left until you have one number remaining on the left side of the decimal place. Watch. 1, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots. 6 spots would put the decimal place there, 3.42, and we moved it 6 spots times 10 to the 6th. That would give us answer choice A, scientific notation. Problem number 8 deals with square roots and also variables that deal with letters. That reminds us of kid logic. So first of all, when we look over here, it tells us that the square root of our variable x is going to be larger than 4, but it's going to be less than 9. So if you look over here, let's just take 4. 4 times 4 is 16. So you know for sure our number has to be larger than 16. Okay? On the other end, it's got to be smaller than 9. 9 times 9 is 81. So you know that the range for our x value has to be between 18 and 81. If you look over here, we can cross this out because that's not in there. That's not in there. That's not in there. This is too small. That's out. And 18, it is larger than 16 and less than 81. 9 times 9 is 81, so you know that we could go 8.89 or 8.99 or something like that, so it would be less than 81. E is the correct answer when you look at it from that perspective. Problem number 9, it's a cross multiplication problem. What you do is you simply set this up and cross multiply. It's 6 times 8 is 48. And 9 times x. So 48 divided by 9 would give you 5.33. And you find that in your answer choices. The only one close to that is A. Once again, you see fractions. Simply divide them out to get decimals. 1 divided by 3 is 0.339A. Problem number 10 is a harder problem than you think it is. Just use a little bit of brain power. Instead of trying to figure it out the fancy way, just use a little bit of brain power. Kid logic, kids. If you look over here, it says we have X apples equals B cents. So let's say that we had 3 apples, and each apple was 10 cents. So how do we find out the total? 3 times 10 is 30. All right, now they're telling us that we need a formula for the cost of Y apples. That means Y is going to have to be multiplied by B cents. So it's going to be BY. That means that BY has to be part of the formula. When you come over here, look at answer choice A, there is no BY on the top or the bottom, and therefore that can be crossed out. B, there's a BY there. We put a dot by it. This can be crossed out. No BY. There's a BY on the top. Put a dot by it. And BXY, that can be crossed out. We reduce it down to 2 answer choices. Now, if you have X on the top, for example, if you have 3 on the top, and then you have B times Y, say that we have B is cents and Y is like the number of apples that we have there, and that would be 4 times 10. This is 40, so it's going to give you like a bigger number. Well, if you take a smaller number, the number of apples, and multiply it by BY, you're going to see that you get a small number. Chances are you're probably going to get a fraction. Okay, so can you have a fraction for an answer? Whereas answer choice D, if you have B times Y on the top and then divide it by the number of apples, then this would be a smaller number, and since these two are multiplied together, you would have a larger number. A larger number divided by a smaller number is still going to give you a larger number. So the logic comes down to this. Which one is going to give you the correct formula? Is it going to be a small fraction or a larger number? Chances are, since you're taking the number of apples and multiplying it by a certain amount of cents, the answer is going to be larger, and therefore just using a little bit of common sense, kid logic is what I call it there. Answer choice D is the correct answer. There are other ways to do this particular problem. If you're interested, feel free to check with Professor Thomas, Professor Maracek, or one of the Genius assistants. Problem number 11 is a percent problem. First things first, always remember to write stuff down. So first of all, we have 12 students, and that equals 25% of the class, and those kids received an A. So I write that down. 12 equals, and then convert the percentages into a decimal. 12 equals 0.25. So when we think of this as a kid, we see that 25% of the class is 12 kids. So if we say how many 25%, equal 100%? Well, you see that we have 4, 25, 25, 25. So this would be 25%, 25%, 25%, 25%. And then you just simply add them up. 12 times 4, 12, 24, 36, 48. Correct answer on that one for 11 is E. Percent problem number 12. Tricky one, kids. Think kid logic. Kid logic tells us that we like numbers. Remember, whenever you see an X or a Y, just pick a number, a random number. So here it says, this year, 75% of the graduating class at Harriet Tubman School took 8 courses. Well, I don't know what that is. So you know what I did? I just said that the graduating class equals 100. Just pick a random number. 100 is great because that's a percentage number. All right. So 100 times 75%, 0.75, means that 75 kids took 8 math classes. All right. Out of the 100 kids, who's the remaining amount? We have 25 kids remaining. All right. Then it tells us of the remaining, instead of just a remaining mystery number, we now know that the remaining number of kids is 25. Okay. So we have 60% of the remaining kids. All right. So 25 kids times 60% of them, right, equals 15. Of the 25 remaining kids, 15 of those kids took 6 or 7 math courses. All right? What percentage of the graduating class took fewer than 6? Well, if we have 25 of the remaining and then 15 took 6 or 7, 25 minus 15 will give us 10. 10 kids of the remaining ones did not take 6 or 7 math classes. So the answer will be 10. That will lead us to answer choice B for problem number 12. Problem number 13, test score averages, very common on test day for ACT. Let's go ahead, take a look at the format. Remember this formula, kids. You might want to write this down. First things first, here's the problem. Adam took 7 tests, did a miscalculation, and only divided the total number of test score points by 6. And when he did that, he got the incorrect value of 84. So remember this format. The format is this. You take all the tests and add them up and then divide by the total to come up with the average, right? Part divided by whole gives you the average. So we know that we have 7 tests. That's what it tells us. So let's call each test X. X plus X plus X plus X plus X. And we're going to do this until we hit 7. So we have 7 X's on the top, okay? Now, Adam did a miscalculation, and he divided the total by 6. When he did that, he got the wrong average, which is 84. Okay? That's our setup. Now, what you can do is you can go the reverse process once we have this set up. You can say 84 times 6, which gives us 504. And 504 represents the total of points from all 7 tests. Now we know that Adam did not take 6 tests. Adam took 7. So we replace that. We get rid of 84. And then our X values up here, let's simply go ahead and put that up here. So we have 504 divided by 7 tests, and that will be 72. That gives us answer choice B. The other way you could look at this is when you see that Adam divided it by a smaller number, you know that the average is going to be higher, because when you divide it by a larger number, the numbers are not going to go this way, larger. So those two answers could be knocked out right away. And you already know that it's not C, because it tells you in the problem that it's not 84. Adam was incorrect. So you reduced it down to 2. The correct answer, therefore, for 13 is going to be answer choice B. And finally, problem number 14, it's percentages again, dealing with test scores. As I mentioned earlier, we like using numbers that are easy to work with. So let's start off, underline all the things that are important. We have 50 students. It looks like of the 50 students, we have 35 of those students are juniors. Label everything. And the remaining 35 students plus the seniors are 15. 35 and 15 gives us the total number of students. All right, when I look at this, I don't like the numbers here. So what I did is I went ahead and got up to 100. So here we have 50. So let's just say that we have 100 students. If we have 100 students now, of the 100 students, how did we get 50 to 100? We simply multiplied it by 2. So that means if we multiply the juniors, which are 35, by 2, we see that we get 70 juniors now, and we get 15 times 2, which is 30 seniors. All right. Now, what we're going to do is we're going to multiply that by their test scores. The juniors, it says here that the juniors scored 80. So, if they got 80 points out of 100, that's 80%. So let's just put a decimal in there. That will be our brackets. And the seniors got 70, and let's just say that that's 70%, because we're dealing with 100 now. See how easy that made everything for us? And then let's simply just calculate it out. Those are brackets, by the way. 70 times 0.8 for the juniors will give us an average test score of 56. And for the seniors, 30 times 0.7 is going to give us 21. All right? Add those two numbers together. 56, 66, 76, 77 would be our converted average score, and you simply look for that in your answer choice. That gives us answer choice D for the last problem, problem 14. What's next, Professor? Some of you may be asking that question. So we have two options. First things first, if you feel like you need some more practice, those long pre-algebra word problems converting text into mathematical formulas always were a pain in the rear end for me until I took college physics. So if you feel like you need some more practice, go to our online training website, www.jrgeniusonline.org. Once you log in, go to the tab that says Games. Under the Games, look for Math, and then go ahead and click on Pre-Algebra Math Game. If you feel like you got this down pretty well, we're going to move on to the next Brain Blast for Math.